this video, we are going to check whether a given signal is energy or a power signal. So signal given is like this. Let's plot the signal first. Since u of n is given, that means signal will start from 0 and go up to infinity. So for n equal to 0, I have 1 upon 4 raised to 0, which is 1. So this is 1. For n equal to 1, 1 upon 4 raised to 1. So it's a 1 by 4. Then we have 1 by 16. Then we have 1 upon 64. So on and so forth. Okay. Important thing here to note is signal is getting converged. What is the meaning of signal is getting converged? As n keep on increases and tending to infinity, signal die out and become a 0. That is very, very important. So signal is converging in this case. Once this is the case, let's determine what could be the energy and power of the signal. So being a discrete time sequence, the energy is E infinity equals summation n equal to minus infinity to plus infinity mod x of n square. So once again, being a unit step getting multiplied with this signal, total signal exists only from 0 to infinity. So E infinity I'm getting as summation n equal to 0 to infinity mod x of n square will be 1 by 4 raised to n, and u of n means it is 1 whole square. So if I simplify, I will get this equation. Now I need to find out what is this summation will give me. For that purpose, what I will do, simply I will place n values over here and get a series. So E infinity I'm getting as, if I place n equal to 0, 1 by 4 raised to 0, then for 1 I have 1 by 4 square plus 1 by 4 raised to 4, so on and so forth. So if I simplify, I'm getting a series like this. E infinity equals 1 plus 1 by 16 plus 1 upon 256 like this. So now it becomes a simple problem of maths. These terms are in geometric progression, and the sum of geometric progression formula we need to remember. So for terms in GP, geometric progression, meaning I have this 1 plus alpha plus alpha square plus alpha cube. I need to get the sum. Don't be under the impression this will be infinite. It will have some finite value, and that is given by 1 upon 1 minus r. Now we need to decide what is this r. So r is nothing but a common ratio between successive terms. So over here, the ratio, if I calculate between the successive terms, it will become alpha. So here the formula is 1 upon 1 minus alpha. But if series start from a, some constant, so you say a plus a alpha plus a alpha square plus a alpha cube, I can have a formula a upon 1 minus r, and once again r is a common ratio between successive terms. So this is the one thing, and this formula we are going to use over here, because here also I'm getting terms in geometric progression. So a infinity I'm getting as 1 upon 1 minus. If I find out the ratio between successive terms, it is 1 by 16. So if I simplify this, I am getting answer 16 upon 15, which is a finite number. So energy is finite, no need to check for the power. Signal is an energy signal. One thing we have to keep in mind over here while considering the geometric progression, one condition is that over here this r should be less than 1. Meaning what? Series should be converging. This is very important. For the series which is not converging, I cannot use this formula. Let's take an example. I'm having series like this: 1 plus 2 plus 4 plus 8. So it is ever increasing. Since the common ratio is same, but that common ratio is 2, which is more than 1, that means series will never converge. It is keep on increasing. At that time, I cannot use this formula. The sequence or series which is converging, meaning ultimately it becomes 0 for more number of alpha or more number of terms in the series, that called as a converged series, and only for a converged series I can use this formula. Otherwise this formula cannot be used. Hence, in the first place itself, while plotting the signal, we plot the signal, and from here it is very much obvious that signal is keep on decreasing, and in the end it will become 0 for n equal to infinity. Hence the signal is converging one. And only for a converging signal we can find out energy and power. Thank you.